into the stream, folks. I guess I'm mostly welcoming folks who are tuning into the archives, since I figure there's a bit of a delay in folks actually joining live. You know, people jump in and out and whatever. Even the early birds usually take a few minutes to actually join. But all of you who are here in the archives in the future, I can time travel to you immediately. Oops. Let's not have the audio also going. Sorry. All right. Let's just get back into it. It is a Saturday night here. I don't think it's actually quite started raining here yet, but there's some serious weather scheduled to come through here this weekend. I was just outside clearing the gutters to try to, they were basically full of like dirt and decaying leaves, and I figure a giant rainstorm would not do that any favors. This cat is so wonderful. Hey, Tuco. Are you getting up now? Oh, he's a good little tiger. He really likes chewing on things, and I guess one of those things now is my microphone stand. Little guy. Anyway, Tuco. Okay, I guess I'm not introducing the stream right away. I'm actually hanging out with Tuco, which is cool. Oh, do you just want me to open the door? Hey, Tuco, what do you want? Do you just leave this open? Yeah? Okay. Fine. So that's the cable we repaired on the last stream. So I'm gonna do another test to see where we're at with resistance. This is an LCD monitor with a touchscreen, currently upside down. We did a little bit of a detailed repair on this cable in the last stream using conductive epoxy, and then in between streams this morning I put a couple of coats of clear nail polish on it to protect it. And I tested it this afternoon and it seemed to be working all right. I was measuring the resistance between these pairs of wires on the touchscreen, and it seems like they're nominally around 15 or 20 ohms. And this one defective pair had been reading, like hundreds of kilo ohms to a mega ohm. And so this afternoon it was reading like 50 ohms, which seems like it's workable. Let's see where we're at now. I'm going to measure it on this connector end so that I can have all that just assembled as it's actually going to be used. Hey, welcome to chat, folks. Oh, Tuco wants back in. Yeah, you want back in? Yeah, what are you talking about? Tuco, you're so weird. Yeah, I don't know what's up with my sleep schedule either, but it seems like whenever I stream, someone's going to be up at the same time. So I'm glad this worked out. Welcome. Can we has meter? Tuco's making me nervous already. So where are we at? Ohms. That one used to be 20. This stuff seems pretty variable. Maybe I'm not making good contact with the probes this time. So this is the one we repaired, and it's actually doing the best of them all so far. Oh, come back. Is that right? These might be reversed. Okay, yeah, so I think these are reversed. I think the ones that we repaired previously would be the orange and yellow wires on this connector. So third and fourth from the right, whereas they're third and fourth from the left on this side. So yeah, 350 ohms. Not ideal, but workable, I think. What else do we have though? 40 ohms. Ohms, which is good. 20 ohms, good. Tuco, you want out again? 38 ohms. Yeah, okay, so I don't know how much of that is my contact to the connectors, how much of that is the epoxy still needs more time to cure, how much of that is like I messed this up and it's just bad. But my hunch is that, under a kilo ohm is probably fine. So I think just to see where we're at, I think this was already configured to boot the original firmware. That's what's in the card slot already. So I think we just boot the original firmware and see if the touchscreen works, just to see where we're at with this fix. Tuco, what do you want? Do you actually want out? No, do you just want attention? What? Okay. All right. Tuco do go meow. That is a thing he do a lot. I love him, and he go meow a lot. Sometimes too much. Oh, I saw this Go probe connected to this serial mouse, serial touchscreen port. Okay, putting that back in. And let's put this back into landscape orientation. Okay, this is going to be in the wrong orientation for the original firmware, but this is where we'll want it later. Just giving the rest of the setup a once over to make sure nothing is connected incorrectly. Can't quite see the original power supply board. It's actually kind of hanging under the desk right now. It's not very important, just in case anyone was wondering where that went. Guess I don't really expect the calibration would still be valid. Gosh, this thing takes annoyingly long to boot in the original firmware. If the touchscreen calibration is bad enough, I won't be able to press the button to enter the touchscreen calibration. The way around that is to reboot while holding down a button. That's a good sign. Why are there so many? I think that worked. Yeah. I guess it went through more cycles because the calibration was different enough from what it had stored, but then the second time I went through it, it only went through one cycle. So I won't be able to test the touchscreen much in the original firmware, but in the DOS driver, it was pretty, more responsive than I expected it to be. And our Linux kernel should have a driver for the touchscreen. I haven't read the documentation for it, so we'll have to probably add some command line options to configure it properly. Alright, so on the last stream, we used Docker to build a Linux image for this thing. Oops, sorry. And right before this stream, I copied it to a compact flash card, and I'm going to see if it boots. Oh, what does that mean? Oh, I haven't set the... I need to set the BIOS disk geometry back. Interesting. Invalid argument. Oh, that could mean anything. Invalid argument. Say that again. It's weird that it got an okay at that point. Yeah, gosh, what other BIOS disk options do I have? Oh, man. This is all terrible. Gosh, what could invalid argument even be? Oops. Gosh. Ugh. Booting Linux failed. It's the most unhelpful error. Like, there was an okay after loading the image? Right, booting kernel failed. I don't even know if that's coming from like really early kernel or if it's coming from syslinux itself. Could try loading something else with syslinux. I think there are other executable formats syslinux knows how to open. How's everybody's Saturday doing? Or is it already a different day where you are? Is there any kind of debug option? Should contain no compiling. That's interesting. Somehow I doubt whatever's going on here is going to be in the common problems file. It might be fun to run memtest on this. It would also be just a thing we could run to test the bootloader. Oh gosh. I forget the politics of memtest 86. A USB stick. Can I build it myself? Bootable binary. I think that's what I want. I think this is probably a multi-boot / Linux kernel. think we can just boot that as a Linux kernel as long as we rename it. There's a comment that git logs show that the booting kernel failed. Invalid argument is a syslinux change introduced 7 years ago. The error is a change, or like the line that would print that was like first added, do you mean? So ext Linux seems handy. It's like I don't need a separate boot partition. I can just have a single ext 2/4 partition taking up the whole disk. I was having a problem with that earlier, where ext Linux does not know how to replay an ext3/ext4 journal. So I actually have to be sure to write the kernel and the bootloader to the file system with the journal disabled. And the easiest way I found to do that is just to make the file system as ext2 and then add the journal once I'm done populating it. Since journaling seems useful for all of this, I don't want the base image to be like contained in a journal that still needs to be replayed by the time the bootloader gets there. All right, there's our ext2 image. Got our extlinux.conf, loadlinux.sys and .c32 are part of syslinux. And then our BZ image. We just call that memtest. Interesting. Invalid argument. Guess we're reading some syslinux source code. That's a good question. This is a Gentoo compilation session. No. I wasn't sure how much of this I would have to compile. There were some instructions online for compiling Gentoo for 486. It seemed like I would definitely want to customize the kernel. Would want to like choose what options are built in and disable modules entirely probably and just keep it all small. But as far as user space, it seems like 32-bit Alpine might actually just be fine for what I'm doing. So my plan at this point is to use a small 32-bit Alpine root FS as a base system, install some packages into there, and then just cherry pick files I want out of those packages, because my compact flash card is kind of small. But my problem now is that this thing that works in QEMU is not actually working on the real hardware, and it seems to be stuck in syslinux. So yeah, the way I've got it right now, I can just actually look at what's going on here. I clean this up very slightly between streams. So I have this entirely built in Docker, just for convenience. Oh, why is this so little? The only files outside of the Docker file are really just the kernel configuration and a little makefile wrapper just to help build it and extract the disk image and then run the disk image in QEMU. And the Docker file so far has 2 sub-images within it. I've got one just for building the kernel, just a pretty vanilla Debian that I download and build a Linux kernel in. Pretty straightforward. And then the other one's a bit weirder. This one, my vision for this was that it was partitioning the image and doing like the final image assembly. So far this is kind of involving itself with 2 separate disk image files. There's what it's calling the base image, which is an ext4 file system containing an Alpine Linux root FS. And because we don't have networking inside the QEMU, so there are these 2 conflicting requirements, right? So the Docker is here for convenience, but the Docker does not give us the ability to actually work with like devices or disks in any sort of way. Unless you go to using privileged Docker containers, but I think that's just like philosophically objectionable, so I'm not going to go there. So I wanted to actually build things in user space, and I can do most of that just fine. I can just assemble a file system and then use makefs.ext4 or makefs.ext2. I'm using both of these here for different purposes. I can use those to just assemble a file system image and use fdisk on a flat file and just like build everything without having to use a loopback device or actually mount anything. The one place where this breaks down so far is actually trying to install ext-linux. So I'm doing that inside of a QEMU emulation. So inside Docker, I'm just installing Debian's QEMU package and then using that to run just coincidentally the same kernel we just built, although it could just be whatever kernel is handy. And then using it to run this shell script that completes the initialization. And so this doesn't have network access. So this is using Alpine packages that we installed in a chroot up here. Yeah, that's just this thing. So yeah, outside of QEMU, we just splat the resolve.conf into the base image we unpacked, chroot in there, and then use APK to add some packages, and then those are available inside QEMU. And then inside QEMU, the thing that's special, we don't have networking there, but we do have the ability to make fake disk devices without requiring special privileges. So inside Docker, I can use QEMU to just run this script and actually install ext-linux. One thing I added between streams is I wanted to have a better way for the actual Docker file to verify that this reached the end successfully, because I'm not actually passing through status information on return. The way I'm actually exiting this is just, I'm having this kernel panic because you reach the end of a init. So really all kernel panics look the same. And I'm just telling it to reboot on kernel panic and then telling QEMU, no, actually don't reboot. If someone tells you to reboot, just to quit. So it's very hacky, but then I'm using I'm just like overwriting the beginning of the base image device to signal that I'm done, and then checking that down here. Anyway, that's a little hacky, but it seems to be pretty easy to update, and it's working all right. At least in emulation. On real hard, we're hitting this invalid argument error. Invalid argument. So I guess we're downloading syslinux source code. Let's see. Ooh, syslinux is actually hosted on kernel.org. That's cool. What version am I running? It would be cool to match up versions here so as not to be chasing ghosts. Okay, so I'm now inside Docker, and then furthermore inside a chroot in the Alpine image that we extracted. So, love to be using Alpine, Debian, and Arch all at the same time. And Windows, because that's what I'm streaming to you from. Alright, so I just wanted the version for now. This will be useful later. 604. Wow, 604 isn't on the mirror yet. Is that real? Oh, this is a pre-release. Interesting. Well, I guess we could just look in the repo if it's that new. It is nice to occasionally be running stuff on an actually fast and actually spacious Linux machine. This machine is a bit larger than the one I was running demos on before. Oh. Yeah. Anyway. So, messages. Oh, what was it, like booting kernel or booting Linux? Let's just run this again. Booting kernel failed : invalid argument. Alright, this is just going to be some like really high level catch-all, though it's not going to be helpful. Right. This should not return, but here we are. Okay, but that's the starting point, though. Like, we know something in that giant bucket is what failed. Sys Linux, boot Linux. News. Is that not the same file? Suddenly getting feelings that this might be the wrong bootloader to use. Oh, how do I get all these dprintfs? That's not on by default, is it? Serial port debugging? Ah. That's what I want. Is this... Am I just gonna have to compile this? I was hoping that would show up in like one of the .in files or something. Or the documentation. Okay. Where do I want to compile that? I guess in that root environment. Bad ideas. Oh man, I should probably do this in Docker properly instead of just like hacking it, because this is going to be extremely annoying. Pearl. Oh yeah. What's that called? What I want. Oh, make files. It looks like they generally use plus equals when they're working with C flags in the make file. It sure looks like something essential was getting overwritten when I was redefining C flags in the command line, though. It's in that core make file. flags. What's that supposed to be for? Oh, maybe that's what they want me to use. Opt flags. Yeah. Makefile was happy with that situation. Oh, do I just not even actually have any libc headers on this? Is this? I was assuming it was a path problem, but. That's better. Yay. More errors. Can we disable ACPI? I just don't care that this is broken. Interesting. Why would that be multiple defined? Oh. Yeah, okay, that's a bug. Why is that written like that? They're defining actual data in the headers, not just like declaring the data. It's not usually what you want to do. Usually you only want to do that in the .c files. So is that what they meant? Are they intending the linker to do something with that? Can I just disable this entire module? Is this because I'm compiling git top of tree? Is there like a tag I should be dealing with? Presumably the one that ships in Alpine actually compiles. Which pre was that though? Pre1 R9. Okay, let's try this tag. Oh gosh, make clean slowly, why don't you? Man, sometimes putting together a Linux distro feels like wandering around a junkyard and trying to figure out which car parts go with each other. Oh, we're still hitting this. There's the question about why I can't just run like a regular Linux ISO. Part of what's going on is that this like needs at least a custom kernel, so I could like start with an existing ISO and modify the kernel and strip it down a whole bunch, but like that's basically what I'm doing. Like I'm starting with Alpine Linux and a custom kernel and then building an image from that. Like basically this is just the normal process of customizing a Linux install so that it works on a particular weird piece of hardware. That's the theory, at least. The thing that I'm debugging right now is that it wasn't booting, so I need to compile a version of syslinux that has debug support so that I can try to figure out why it's not booting. It seems like that header meant to say extern. I don't know. Is this just a general compiler compatibility problem we're having now? Why are we doing this? I mean, first of all, yes, of course, this has its own get-opt, because it's got a command line, and it's probably compiling some libraries without any kind of libc in them, right? So it's got its own little tiny included libc. Caleb-C, is that what we're doing? What tools am I using? GCC 10. I'm guessing I need this GCC 10 dot patch. -D multifs. That would do it. Telling the linker to allow multiple definitions in a bunch of separate places. Sure. Let's just grab that. I could add that to LD flags, right? Patching a bunch of separate make files. Why is that patching the wrong file? can't find it. Okay, I guess it does actually include that A and B at the front of the path. Cool. Any luck now? I'm still on the fence about actually like checking in something that builds this versus just doing a one-off build to test this out. Python. I don't think I can just grab the individual files though, like this might actually be annoying to install unless I just do this build in the Docker setup that I had. Oh, I also need NASM. I don't suppose there's an easy way to build an Alpine package, but with some extra environment variables. It's a question about what came before libc. I mean, I think the concept of libc has, as far as I know, existed as long as the C language. There was always the idea that C had some set of standard library functions that were supplied with it, and there have been various implementations of it. I mean, the libc that most people think of when they just talk about libc on Linux is usually glibc, but Alpine here uses musl by default, which is an alternative libc, and there are several other libc implementations that people have made. And then there's a question about whether you could have set up a custom kernel that just boots an encrypted VM. I mean, yeah, you could totally. I mean, VMs are pretty modular, like Lego components at this point. You can set them up in all sorts of different ways. lots of people do pretty much just make custom operating system distributions that just run VMs. Some pretty popular ones are like VMware ESX or like Proxmox. Like it's a pretty common product that people have now. And yeah, you can have that layer do the encryption and just boot right into something else. I've actually found that it's a little more convenient to just have the OS that's inside the VM do its own full disk encryption, because then that whole image remains portable to different environments pretty easily. Whereas if you had encryption done in the virtualization layer, then that layer would have its own way of like unlocking the images and managing its keys. And I've had more luck with just doing like regular Linux full disk encryption and then sticking that whole thing in a VM. Oh, XC. Oops. I'm just going to look at my shell history and stick all this in the Docker file and sort it out. This is looking good so far. Are we building... We're building a DOS exe here. Is there another patch that handles this? Sounds like the weather's starting out there. It is raining. I don't know if that's it. I can try this. There's a comment in chat that I like rain. I do like rain. I'm a little concerned about this one because this is supposed to be a fairly large storm. But yes, generally I like rain. suddenly very little patience for this. I should just learn how the normal APK build process works. This is hitting Android spam. Oh, Tuco wants in. Hey. How are you? Gosh. I'm getting a little bummed out by all this Linux yak shaving, but I should not lose sight of the fact that I think we did actually fix the touchscreen. I don't want to speak too soon, like it's been flaky this whole time, so maybe we're just getting lucky, but all signs so far are that the touchscreen cable is in better shape now. Oh, a build. Backspace and command are literally right next to each other. It's a go. Temporary error. Weird. Yeah. Zuko is climbing. I don't even know if there's like a proper way of doing this. I might have to write a script that downloads this, patches it, like patches the APK build and then builds it. That's so annoying just to get a debug version of syslinux. Zuko, what do you want? I could also just start again here using the exact sources that this APK build are using, instead of using the git tag like I was. It'd be cool if there was a way to do an A build with some additional environment variables. Oh, I can force run as root, which is probably fine given that I'm inside of a Docker and a root at this point. No focus for us? Okay. Zuko. Tuco. Tuco, what do you want? That chair is basically Tuco's now. He owns it. Whoa, Tuco, don't be chewing. Don't be chewing USB cables, gosh. Seriously. Whoa, what are you chewing? Tuco, what are you chewing? What were you just chewing, Tuco? Did you just eat a bug or something worse? This cat. So I think I have to clone this and then patch it and then A-build it. Let's try that. What is the actual URL of this? Can I just clone this? Are you chewing stuff still? Hey, what are you doing, honey? Where's the actual Git repo? Oh. Is A port the tree? Do I have to clone the entire? Gosh. Oh my gosh. Yeah, let's do this in the Docker so I don't have to redo it. I wonder how much bigger the debug version of syslinux is. Ugh, this is annoying. There's gotta be a better way to do this. Like, several better ways to do this. What is the minimum setup to build a customized Alpine package? Is this Linux? Can I just set environment variables outside the build? Will that work? Maybe that's enough, actually. So that'll run inside the chroot. Those files will be available later when we do the QEMU stuff. All sorts of reasons why that might break, but let's see if it works. I'm almost certainly going to need more packages. Let's just see how far this gets. commented in the chat that syslinux doesn't need to be installed. It's just a file you copy in. That's not actually true. You do actually need to set up the volume boot record, and I think it needs to do something special to indicate the position of the LD Linux file, but I'm not sure about that. I know I don't have to use the Alpine build system for this, but I tried just building syslinux without referencing the Alpine package, and I was having problems related to the GCC version. So the reason the Alpine package seems helpful is that it's a reference for something that I know works, because I already have, the binary is fine. The only thing that I need different is that I want to compile this with a debug flag. Oh gosh, is this actually taking this long? And I do need to compile syslinux. Downloading a binary is something I can already do, but that doesn't give me the debug version. I don't know if this is actually running or not. It's probably working. Okay. It's just a pretty slow step. We need a build. Do not a build. Yes. I'm not gonna make a user inside the 2 layers I've already got here. I. Is that no longer an option? Error syslinux all failed. Oh, I guess I need a build dash I. Or a build dash I build. EFI. How do I not EFI? Oh, package is making BIOS also. That's interesting. Maybe that's fine. Right, I don't think my command line or my environment variable is making it through either. This is like a whole different yak shave than I was expecting. I didn't realize it would be so annoying to get a debug version of syslinux, or that the error I would get would be so unhelpful. I was hoping we would at least get into, like, decompressing Linux. Tuco's pretty peaceful, though. Is it not actually unpacking the source? I think that part was working. Right, it's got a directory up there that doesn't seem to exist. Like, I don't know why it would just not unpack this file. Maybe because we don't have XZ. Is that really it? That was weird. Okay, where does aports usually do the packet or the patching? Well, I should probably wrap up this stream and go read some documentation and then take like a more proper stab at this without being quite so stabbing in the dark without understanding the Alpine package system at all. Yeah, there are a bunch of workarounds to this. Like, I could try compiling syslinux on an older GCC or a different distro, or I could just, I don't know. I could just have a separate Docker container that I don't try to use any build automation for, and I just hack this together. I just want something that'll give me some debug output. for anybody who didn't see it earlier, I can show like what this is actually doing when I try booting it now. That is as far as I get, and then it'll shut off soon because of the watchdog timer. It kind of seems like it might be useful to patch syslinux with the watchdog timer code. So yeah, I'll do a little bit of research on that and get a little bit of sleep, and we'll come back tomorrow with a plan for how to actually approach this. Thanks for joining me today. Seems like that epoxy repair is holding up so far, but I haven't been able to test it a huge amount. But yeah, I guess that does it for today's stream. Thanks to everybody who stopped by and hung out for a bit, and a special thanks to everyone who chips in on Patreon to keep this going. I will see everyone tomorrow, and we can continue doing projects and hanging out and doing the various online technology things. And hopefully we don't get too soaked with the rainstorm. Today and tomorrow we're both supposed to be pretty wet. Oh yeah, documentation bedtime story. Yeah, reading about a build is sure to be a bit of a snooze. Anyway, I'll see you tomorrow. Happy hacking, folks.